Alright, so I'm going to do a small video on scientific notation. And scientific notation is invented in order to write very, very large numbers, like the number at the very top that you see here, Avogadro's number, the number of atoms in a mole. It's one of the largest numbers that students will encounter in high school, and then for very small numbers. So there's nothing particularly scientific about it. It's just that scientists have decided that this is the notation they will use to write large and small numbers in shorthand. And so in order to write a number that's very, very large, you count the number of zeros, starting where the decimal is either written or understood to be, and then you stop until there's one non-zero digit to the left, in this case a 6. And then you count the number of places that you move the decimal. So this number in scientific notation then would be 6.02 times 10 to the 23rd, and it's the number of atoms present in a mole of any substance. So we counted the places, and luckily I have commas to separate the zeros every 3 zeros, so 3, 6, 9, 12, 15, 18, 21, and 2 more is 23. So I moved the decimal 23 places and then stopped it. And so this makes it a lot easier. Instead of counting zeros in books and documents and papers, it's much easier just to look at a number to see what the magnitude of the number is. So the 23 is sometimes referred to as the magnitude of the number. It gives you an idea of how big the number is. And then when we write very small numbers, you're going to move the decimal again to the right, in this case, and stop it after the first non-zero. So we're going to write this number as 5 times 10 to the negative 6. And this represents the typical width of a single-celled organism. And that's why I chose this one. So 5 times 10 to the negative 6 meters. Now, if you have numbers that are written like we normally see them, this is sometimes called standard notation, as opposed to scientific notation. Let's say you see numbers that are written in scientific notation, like I have here, and you want to rewrite it in standard notation. Then you just reverse the process. And in this case, I'm going to move the decimal 11 places to the right. And so this counts for 2 places, so I have to put in 9 zeros as placeholders. And we're not going to get into significant digits in this video because I try to keep the videos nice and short and maybe save that for another video. In this case, you're going to start where the decimal is written for a very small number and go the opposite way. So 0.000 000 000 000, that's 9 places, and I need 12. So I'm going to need 2 zeros and then the 5, the 9, and the 1. So the decimal started right here, and unless I miscounted, I moved it 12 places to the left. Here I moved it 11 places to the right, and that gets us back into what's sometimes called standard notation for our number. But these numbers are very difficult to read over and over and over again, and if you lop off a 0 in counting someplace and miss a 0, your result or your number or your number is going to be off by a factor of 10, either 10 times too big or too small. And that's the advantage of scientific notation, is that it's very easy to keep track of your zeros.